Following on from the previous video, we got to this stage here where we suspect we're at a local minimum because everything is concaving up. So we suspect we're at a local min because everything is concaving up. But everything concaving up doesn't necessarily mean we're at a local min. We need to compute this quantity. If this quantity is bigger than 0, then and only then can we conclude that we're at a local min. But we need to compute this quantity. So to compute this quantity, we need fxx, we need fyy, and we need fxy. So let's compute xx. So computing xx. We've done fx already. Fx was given by this. So if we want xx, we need to differentiate it again with respect to x. So differentiate this with respect to x. That will then give us this. Now evaluate it at our point. Remember, we're trying to investigate at the point 0, 2. So put this into the x. There is no x, so forget about it. Put this into the y. It then gives us this. So we can see that fxx, this value here, is evaluated at 0, 2. Well, we've got this value here. So now we need fxy. So fxy. So now looking at this, we've got to differentiate it with respect to y because we're doing it with respect to y now. So differentiating that with respect to y would then give you this, and then evaluate it at 0, 2. So now if you put this into the x, put this into the y, this whole thing here would be 0. So we've done this, and we've done this. So now we need to look at fyy. So fyy, well, from above in the previous video, we've done, I think we've done this. Well, anyway, differentiate the, take the partial derivative of the function with respect to y. That will then give us this, okay, and then differentiate it again with respect to y. That will then give us this whole thing here, because, well, if this is like one block, this is like another block. So so if you're doing it with respect to y, y is a variable, so you've got to use the product rule. So differentiate the first, leave the second alone. So differentiate the first will give you this. Leave the second alone, and then plus leave the first alone, and then differentiate the second. Well, you differentiating this would just be 2y, and then now differentiate this. Well, here you've got to use the product rule again. So differentiate the first, leave the second alone, and then plus leave the first alone, and then differentiate the second. That will then give you this. So you taking, well, fyy is given by this. So we've got fyy. We need to evaluate it at 0, 2. So we need to evaluate it. We need to evaluate it at 0, 2. So put this into the x, put this into the y, and so on, x, y, and so on. This whole thing here will then become this. And then if you tidy this up, it will then become this. So now we've got those 3 values here. So fxx is given by this. fyy evaluated at 0, 2 would give us this. And then this turns out to be the number 0. And then when you square it, it still be 0. So this whole thing here will then become this. So you can see that this thing here is a, well, e to the power 4 is always going to be a positive number. So this thing here will always be a negative number. So going back to the second derivative test, we worked out this quantity here, and it turns out that this quantity is less than 0. So that means we've got to look at this thing here, because it's less than 0. Well, less than 0, it means that we are at a saddle point. So what that means is at 0, 2, so remember at 0, this is x-axis, at 0, 2, which would be at 0, 2 would be this point here. You can see that it's a saddle point, because the reason why when we looked at the concavity XX, when you slice it in the X direction, remember this is the X direction here, when you slice it in the X direction, it gave us the impression that it's concaving up. So we suspect we suspect we're at the bottom of the hill, but it turns out that is a saddle point, because if you slice in the Y direction, it's concaving down. I hope you can see it's concaving down. You see in the X direction, it's concaving up. You can see that from here. But it turns out that this is a saddle point. Okay, so now we need to look at the point 0, 0. We're cheating because we can clearly see it's a local min. But let's pretend we didn't know that. So let's test at 0, 0. So looking at 0, 0. So looking at 0, looking at 0, we need to check the concavity. So let's check the concavity. The concavity turns out to be this. Evaluate it at 0, 0. So this thing here will be 2, and then remember we're trying to work out this value here. So hang on. Let's start again. Sorry. From here, differentiate it. So this gives us the concavity. Evaluate it at the origin. So we suspect it's concaving up all the time. So we suspect we're at a min. So that's not sufficient enough. We need to look at this quantity for the second derivative test. So we need hang on, what do we need? We need fyy. So fy is given by this. Differentiate it again with respect to y. That will then give us this thing here. Evaluate it at 0, 0. Then this whole ugly thing here becomes a nice and neat number 2. Okay, and fx, we need to work out fxy. Remember, fxy is the same as fyx. We've done this before. So looking at this, hang on, going back to here, do you want to you've got to work out fxy or fyx. They're both the same. Do you want to differentiate this with respect to y, or do you want to differentiate this with respect to x? Choose the easiest of the two. It turns out that this is easier. So differentiating this, so let's work out fxy. Differentiating this with respect to y will then give us this thing here. Will then give us this thing here, and then evaluate it at the origin. So now put this into the x, put this into the y. This whole thing here will become 0. So now we know that this thing here is the number 0. Is the number 0, and we worked this out to be the number 2. Earlier we did this, and it was the number 2. This whole quantity here is the number 4. So looking at the second derivative test, we suspect that looking at this, everything is concaving upwards. So we suspect we're at a local min, and then we got to confirm this by looking at this quantity. Well, this quantity is actually, we worked it out to be the number 4. We worked it out to be the number 4. Well, this number 4 is bigger than 0. So now we can definitely confirm that we are at a min. So we can conclude that 0, 0 is a min. So looking back at the surface, looking back at the surface, at the origin is a min. At this point here is a saddle point. Okay.